Stream function used to get the flow rate. Okay, so two streamlines are drawn in figure this question. There's two streamlines. Okay, and then using the relationship of the stream function with the velocity components. Okay, these are all the velocity components. Okay, maybe this point over here. Like calculate the volume flow rate between the streamlines. Okay, so one big question is that is this streamline? That's what we are talking about. This one is path line. So this follow the same curvy area. So is this streamline or is this path line? I have no idea. And then this is the as they say, this is the position of the particle. Okay, and then this is the xi equation. So this equation is actually Q equals to volume over time. So it's the volume flow rate. Okay, so it's the rate at which it changes. Okay, so I think this is just a streamline. Maybe the path line is some other trajectory we cannot see over here. So the stream, as mentioned over here just now in the video, we actually hold on. We actually see that the streamline itself is straight line. However, maybe because the equation itself, the streamline equation may be some equation, so we don't. So in this case, I don't know. The streamline is a constant, right? Stream value. So I'll just leave you to think about it, okay? While you're watching it, and it just. Nonetheless, let's come back to this equation. I mean this problem first. So the xi is the volume flow rate of the particle itself, and then as you know, volume is distance times area. So this is some distance times the area, and this distance, it says is u. Is actually the direction going in the x, maybe hold on a while. Okay, going in the y direction. Okay, going in the y direction. So this is why I actually choose u. That's why there's a little complication between u, because from here it says that u is the velocity of the particle in the x direction. While if you were to come back to here, u is equals to the partial xi over partial y. So you are differentiating y. You are differentiating y of the whole equation. You get what I mean? So if you are differentiating the xi in terms of y, okay, you're saying that the x is constant, right? Which in this case opposite. Okay, so this is why you have to be very careful which u you start in. So in this case we are talking about um you know the streamline. If you are talking about a streamline and talking about a gradient, so nonetheless I would recommend you go and use this equation. Okay, if you are talking about path line, okay, you use this equation. So this is why a path line they use this one, and streamline they actually use this equation. So as streamline, I would recommend if whatever thing that deals with streamline, you can use u is equals to this. If it's whatever thing that deal with path line, then you use this equation. That would be the best. So if you are talking about streamline, then you just use this one, u is equals to this, and then you do an integration. Okay, you get what do you get? Okay, a bit tired already. So we don't do integration. They didn't call us to do. But you see, as if you remember, there is this equation that comes in all along. If you remember, we have this that comes from this equation. If you remember, okay, the if you were to partial the whatever equation that I'm doing, if you don't understand, you just head back to my video on where am I also don't know where am I on streamline value and visualizing it. Perhaps this two, one of them. you just quickly go and check it out. I don't know what, I'm pretty tired. See, I'm lowering my voice already. It's 11 already. Nonetheless, let's come back here. So, yeah. So using this equation, if you remember, okay, this is another thing you need to put inside your toolbox. You need to remember. So you know that this is the thing. And as you know, dx is equals to 0 because there is no, you're talking about the y changes, you're not talking about the x. So you would assume that x change in the x is actually 0. So therefore this whole thing is equals, dx is equals to 0, right? So this whole thing becomes 0. So dxi is equals to this one. So dxi is equals to this. Then you just sub this dxi back into here. So you have the integrating in terms of dxi goes to this one, and then you have xi2 minus xi1. So the difference between the flow rate from, this xi is actually the equation for the streamline. Okay, this is the equation for streamline. If you were to take back the analogy, it is the equation for the c equals to xy. If you remember my equation back then, it is c equals to xy over here. So this is actually the c is actually our xi. Okay, we are eventually trying to find the streamline thing. In other words, different values of streamline will have a different steepness of the curve itself. So this is a pretty tough thing. So although it may be like, my explanation is pretty smooth, but look, is this path line or is this streamline? This is the thing that I'm talking about. And then this is only the key issue that I'm really, so maybe in the future tutorial, then we may actually know how to do it. But up till now, let's stop here. So in the next video, I'll do a summary and that's it. Bye bye.